Well, hello everybody. This is Sixby, and guess what? That's my car. So I built a model car, and that's my real car back there. Yes, I took a picture of it. Both my model car and my real car. The point is, we are going to be learning about dilations and similarity, okay? It's real simple, and I'm going to keep it as simple as I possibly can, all right? Now check it out. So there's all kinds of different objects out in this world that are similar. Okay, for instance, those cars are similar. Why? Because they're the same shape, but different size. That's similar. Congruent means that they're the same size and the same shape. So therefore, those two cars are not congruent. If they were congruent, they'd be the same size also. So, key point today, similarity means same size, different size, same shape. Like those cars, my model car and my real car. So the one thing that I want to talk to you guys a little bit about is what similarity means, where it comes from, and how it ties to a dilation. Okay? So, this is a dilation right here. We took a small car and we dilated it. We made it larger, a bigger image. Kind of like when your pupils dilate, they go from small to large, but they're the same exact shape. Same thing with a car. This is a dilation from a small car to a large car. Now let's talk about what a dilation is and what it means. Now, for instance, if I just draw my car, I'm going to do the best I can. Just kind of bear with me here. Okay, here's my model car. All right, and I made my real car, so it's giant. Okay, we'll put it out here somewhere. I'm going to do my best, the absolute best I can. Just bear with me. Okay. Anyway, I know they're not really the same shape, but just imagine these being the same exact shape. Now, the one thing that you guys must always know is that in a dilation, if these two figures are indeed the same exact shape but different size, then they will share what they call a scale factor. Okay? Now what does this mean? Well, what this means is if the diameter across this wheel is, let's just say, 1 inch, and the real car is, we'll just say 12 inches. I know it's going to be a lot bigger than that. I'd have like dub deuces on this sucker. But anyway, if it were my, well, yeah, that thing's got 22s on it. But anyway, I'm just saying, just to make it real simple, 1 inch and 12 inches, that means the scale factor is 12, okay? Because you're multiplying every length here on the small model times 12. So what that means, let's say this car, the model car, is 2 inches off the ground. Okay, well, if you multiply that by 12, well, then the real car is going to be 24 inches off the ground, okay? Because that's the scale factor between the two. Now, if that said anything other than 24, then these two cars would not be in proportion to each other, and these would not be similar figures. So any measurement on this car, let's say the length of this thing, let's call it 6 inches long. Well, 6 times 24 is 144. So then my real car would be 144 inches long. All right. Now, the other thing that I want you guys to know is how to find what we call the center of dilation. Now, what we can do in this case is we connect all the corresponding parts of the car. So if I were to, let's say that's the trunk, and this is the trunk of my model car. If I connect those with a straight line, with a straight edge, and it just keeps coming down here, we need basically kind of the point of origination, where it kind of originates. If we take the top of this tire and we draw it to the top of this tire and connect them with a line, they should all meet back here, what they call the center of dilation. Let's take the front of this hood and put it on the front of this hood. If I were to connect those, they will all meet right down here at this, what we call the center of dilation. I kind of think of this as like a projected image also. Where is it being projected from? Well, it's being projected from this point of dilation. That's kind of how you find the point or the center of dilation, is by connecting all corresponding pieces of whatever figure you're working with. If it's my car, then you would connect the trunk to the trunk, and it would, I don't know, the center of dilation would maybe be up here somewhere. Or no, connect those down to here, connect the front to the front, glass to glass. It would be somewhere down here, it'd be the projected image. So that's how you find center of dilation. It's pretty basic. And you guys are just going to be answering some basic questions. There's not going to be a whole lot of math work to do. You just got to answer some real generalized questions about similarity. But just remember, in order for things to be similar, they have to share the same scale factor. Okay? Same scale factor. I'll box that in. All right, so you guys are going to be starting 6.1 today. And I will be in Florida, probably getting rained on. I guess the forecast says lots of rain. So anyway, all right, talk to you guys later.